Imagine every agency keeping its own records, yet all needing the same truth about a citizen, a license, or a case. In this module, we'll design a shared trust layer for digital records that can work across agencies, jurisdictions, and legal constraints, so government can act as one, even when systems are many. Citizens experience one government, but your backends often behave like strangers. Each agency recollects data, reruns checks, and reconciles conflicting records. That fragmentation drives cost, risk, fraud, and, over time, erodes trust in outcomes. Our focus in this module is how a shared trust layer helps reduce that fragmentation without breaking legal or organizational boundaries. Consider a government trying to run a single, integrated social benefits platform. Eligibility depends on income from the tax agency, job status from employment services, and medical status from health insurance. Today, each agency maintains its own systems, its own truth, and its own timelines. The result is delay, inconsistent decisions, and lots of manual verification. A blockchain-based trust layer coordinates these assessments, so one citizen receives one coherent answer with less friction and better auditability. When you design blockchain-based trust systems for enterprises or governments, the real foundation isn't technical, it's legal. Technology must implement what statutes and regulations already allow or require. That means clearly defined legal bases for data sharing, explicit limits on why data can be used, and clarity on who can access it. Architectures have to encode purpose limitation and data protection principles like minimization and erasure, so compliance is enforced by design, not bolted on after deployment. Once multiple agencies or enterprises share a blockchain platform, technology alone doesn't create trust. Governance and accountability structures determine who is responsible for what and what happens when things go wrong. We define clear roles, including which organizations remain data controllers and who sits on joint governance boards. Then we formalize mechanisms, legal agreements that allocate liability, and escalation paths, so issues move quickly from operators to senior decision makers. A permission network is a blockchain where every participant is known, identified, and approved in advance. There are no anonymous nodes joining at will. In a government context, membership is limited to vetted agencies that pass both legal checks and technical certification, typically backed by PKI and hardware security modules. Within that network, some nodes act as validators with right authority, while others are observers that provide RAID-only oversight. Identity and access management is the gatekeeper of a blockchain-based trust system. For citizens, we almost never create new identities. Instead, we integrate with existing national digital ID schemes and enforce strong authentication, typically multi-factor. For staff, least privilege is key, implemented through role-based access control, so caseworkers only see what they need to do their jobs. We also add privacy controls such as pseudonymous tokens to reduce data correlation across agencies while still preserving accountability. In blockchain-based trust infrastructures, data governance starts with clear classification. We deliberately separate routine agency data from highly sensitive records, such as health or disability information. Each class maps to specific access rules, approval paths, and monitoring requirements, enforced directly by the network. Lifecycle rules matter just as much: how long data is retained, when it's archived, and under which legal mandates. The goal is consistent, auditable behavior, not ad hoc decisions. Think of the ledger as the visible tip of an iceberg. Only lightweight proofs go there: hashes of records, consent receipts, timestamps, and decision logs. These let you prove something happened in a specific order without exposing the underlying data. All of the heavy, sensitive content stays off-chain in existing systems: citizen records, case files, documents, and logs, protected by traditional controls. This pattern gives you strong integrity and auditability from the chain, while regulatory compliance and privacy are enforced by a hard rule: no personal data is ever written to the ledger. Immutable audit trails change how oversight works. Instead of sampling logs after the fact, regulators can see every access and every benefit decision as it happens, with cryptographic guarantees the record can't be altered. Read-only auditor nodes expose exactly what regulators need, but nothing more. Smart contracts then enforce policy by blocking queries without a valid legal basis, enabling precise, defensible investigations. Service with dignity shifts us from system-centric thinking to citizen-centric thinking. For citizens, a unified view means they tell their story once, and every authorized agency can work from the same trusted facts. The plumbing stays invisible. Transparency then closes the loop. People can see exactly who accessed their data, when, and for what purpose. Trust comes from clarity, not from blind faith. Interconnecting data across agencies or enterprises doesn't just increase efficiency, it also increases surveillance power. Function creep is the big risk. Data collected for one purpose quietly gets reused for others, like profiling citizens or companies in ways they never agreed to. Over-centralized views create that single-file fear, and automated rules can amplify bias. Blockchain designs must therefore actively limit linkage, visibility, and inference, not just secure storage. Privacy by design means you embed safeguards into both the technology and the governance from day one. On the technical side, zero-knowledge proofs let you prove a condition, like income is below a threshold, without exposing the actual value. Segregation of duties ensures admins, users, and auditors can't quietly collude. On the policy side, mandatory privacy impact assessments act as the gatekeeper for any new data use. For government and enterprise blockchain systems, transparency is not a nice-to-have. It's a core security and legitimacy control. People need clear, jargon-free explanations of what data is collected, how it flows, and who can see it. They also need simple ways to contest automated outcomes and credible public reporting on errors and oversight actions. When users can see and question the system, trust follows. The path forward is about aligning 3 layers. First, use permissioned ledgers as an integrity backbone, not a replacement for every system. Second, define governance upfront. Who operates nodes, who signs changes, how disputes are resolved, and how MOUs encode that. Third, work with legal early so compliance, audit, and records rules are baked into the design, not bolted on later. When these 3 layers are aligned, a shared trust layer can deliver coherent services, strong oversight, and protection of rights at the same time.